Hello, everyone. Thank you for joining the OpenPOWER Developer Challenge Kickoff and Orientation Hangout. Thank you so much for tuning in. As you know, the submission period opened on June 1st, so we wanted to take this opportunity to let you meet some of the experts behind the different areas in the Developer Challenge, take you through some site resources and showing you everything you need to know to get started. And then we want to show you some of the additional resources, in particular for the Spark Rally and the Cognitive Cup, so how to use the Apache Spark and deep learning notebooks in SuperVessel. Also, we have experts here from our Linux team to take you through the Linux SDK. And then we want to introduce you to the IBM XL compilers, which are available to you to use in addition to the Linux toolchain and the GNU compilers. So just to introduce ourselves, I'm Beth Ann Noble from IBM. I'm on the OpenPOWER marketing team. And on our Global Developer Challenge team, we have Serena from DevPost, who's hosting the Developer Challenge for us. She's available in our Slack platform as Serena101, and she can help answer any questions that you have high level about the Developer Challenge, and any problems that you might have with the site or the Slack platform. I just introduced myself. I'm on Slack as well, and our platform is BA Noble. Later, you'll meet Mike Hollinger from the IBM OpenPOWER Solutions Engineering team. He's can answer any technical questions you have about any aspect of the challenge. Also, you're going to meet Randy Swanberg. He's our resident Apache Spark on Power expert. He'll be participating on Slack in the Spark channel. You'll also meet Mike Geschwin from IBM. He's the chief architect for deep learning on power systems. He's going to tell you all about the Cognitive Cup Challenge. And then IP from IBM will give you some great demos to show you what you need to know for using the Apache Spark and deep learning notebooks. Because this is sponsored by the OpenPOWER Foundation, we are very lucky to have participation from technical experts at our foundation member companies as well. So Vinay and Fernando from Xilinx, I don't think they're joining us today, but we'll have a dedicated hangout to Xilinx and using the FPGAs a little bit in the future. We're also going to have, like I said, Yao Qing will introduce you to the IBM XL compilers, and Raphael from our Linux Technology Center is going to take you through using the SDK. We will also have a future dedicated session to NVIDIA and using NVIDIA GPUs, but briefly today I just wanted to introduce you to our resident experts there. So John Ashley, I believe you're on if you want to give an introduction.
Don't really have much to say. My name is John Ashley. I'm with NVIDIA. We're obviously really excited that people will be using our technology on Power to do some seriously interesting work. We're looking forward to seeing the results.
All right. Thanks, John. So wanted to just remind everyone of some key details for the Developer Challenge. We have 3 different ways that you can participate. That was a change from where we started. So you're not limited to any one of these. You can participate in one or all 3. First, it's the Open Road Test. This is a porting and optimization challenge. So we're hoping that you'll bring over your favorite application codes and see how much faster you can go on the platform using the differentiated features of OpenPOWER like 8-way multi-threading. You can also use out accelerators, including both GPUs and FPGAs that are available to you in the platform. Second is the Accelerated Spark Rally. So this is all about combining the power of GPU acceleration and scaling that with Apache Spark. And third, the Cognitive Cup, and this is all about deep learning, and we have some specific deep learning challenges that you could try, or you could solve your own problem. Like I said, the submission period is open. You have until September 1st to complete your submissions. And since we have 3 different challenges within, we're offering 3 different grand prizes. And so that grand prize for an individual or a team who wins any of those challenges will be flown to Supercomputing 2016. That's this coming November in Salt Lake City, Utah. So could be great for skiing or snowboarding if we're lucky with the weather. But this is sort of the premier North American conference for high performance computing and increasingly high performance analytics and deep learning. So we'll fly you out there, we'll give you a platform to showcase your work in front of the of IBM and the OpenPOWER Foundation. And we also have runner-up prizes in each category. So those include iPads and Apple Watches. So now just to talk in a little bit more detail about each challenge, I want to hand it over to Mike Hollinger to tell you about the Open Road Test.
Sure, thanks, Beth Ann. So, like we talked about earlier, the Open Road Test is really about bringing your application to the platform and showing how the application best can leverage the platform, which includes the things like the great memory bandwidth available on the computers and access to both GPU and FPGA accelerators. The key thing here is that we really want to see how the code really performs from a baseline, and then how you can best tune the application by the end of the challenge submission period. So in terms of judging, the top thing really is how impactful is this to the community. For example, if you have an application or a library or a key piece of software that is used by several key processes within a particular industry, bringing that over, showing how it can really leverage OpenPOWER and the Power platform really would be a piece of this. In addition, as we mentioned earlier, using the technologies available, using accelerators, that's one of the key differentiating features available on the OpenPOWER hardware. Finally, in terms of technical achievement, what was the actual code implementation? What was the gain? What was it that you were able to accomplish given the resources that were made available to you?
Great, thanks, Mike. Randy, if you'd like to take us through the Spark Rally.
Sure. Okay. Hi, I'm Randy Swanberg, and I don't see it switching to my screen. Can you hear me? All right.
We can.
So I'm Randy Swanberg, and about the Spark Rally, first of all, I'm leading several development projects here within IBM and systems around Power and bringing Spark to Power and trying to accelerate Spark on Power. So GPUs and Spark is a combination that we're really excited about. So this Spark Rally is, we've created essentially 3 different types of tracks within the Spark Rally that combine Spark and GPUs. The first one is really about if you can take an existing application that is not a Spark application, but maybe it's an existing application that's already using GPUs for some acceleration purpose, but that today is a single node application. But take that application, port it to Spark, continue to use the GPUs underneath that, and just demonstrate that you've now scaled out that application beyond a single node, leveraging Spark as the distributed computing framework. So that's kind of the first tier of possible track that you can do on that rally. The next tier would be maybe there's already a Spark application, or you want to create a Spark application and do GPU acceleration for the first time for that Spark application. That's another one that you can tackle, and this one might be a little bit elevated level of complexity from the first one that I talked about, because here maybe you're creating a CUDA kernel to accelerate some algorithm for the first time and combining that with a Spark application. And there's some resources that are available as well. We've provided some GitHub links, and specifically for this track, there's a package package out there called GPU Enabler, which enables you to code directly from Scala and on top of Spark. It's an add-on package, and you can interact with the GPU directly from your Spark Scala environment and do some innovative, creative things there. The third track in the Spark Rally is really what I would call the most complex, and this is about accelerating something in Spark itself with GPUs. So therefore, the value of what you've accelerated is essentially transparently available to whatever the applications are running on top of Spark that might be using that function. An example would be one of the Spark machine learning library functions, being able to accelerate that on a GPU. And like the previous track, there's also packages in GitHub that show some of the work IBM's already been doing to try and move this direction as well. And you can use that as a starting point, as a reference, to give you even more ideas of maybe how to tackle that challenge. And from a judging perspective, it's kind of similar to what Mike was saying for the open road. It's really about demonstrating the technical innovation of what you've done. What's key here is, obviously, since it involves Spark, is demonstrating that whatever you've created is leveraging Spark to scale beyond a single node. And then, of course, those tiers of complexity that I talked about would be rewarded, whichever tier of that you tackled. And then finally, as a good segue into Mike Geschwind to talk about the cognitive cup, is the ultimate in complexity that the judging criteria will take into perspective is if you wanted to tackle combining the Spark Rally with the Cognitive Cup Rally and essentially do a Spark distributed deep learning type of solution. So with that, I'll turn it over to Mike, and he can tell you about the Cognitive Cup.
Thanks, Randy. So let me walk you through the Cognitive Cup and why we think it's so exciting. If you look at the world around us today and the AI agents that are starting to crop up to help users, whether that's Siri, whether that's other assistive technologies that are increasingly included in many products, it's very exciting to see those artificial intelligence agents built around deep learning, how they can help users, how they can improve the experience that users have. And those technologies are reaching a broad set of applications. If you look at automotive, they're beyond the self-driving cars that are, of course, capturing the public imagination. There are assisted driver technologies, ADAS technologies, automated driver assist systems that warn of dangers in the road. There are security applications that are built on deep learning around image analysis, recognizing intruders, medical, biology, science applications around drug discovery, around petroleum discovery, and of course in media, the deep learning applications help in captioning work to make it accessible to users that may not hear, and that help in search by searching through media, and of course by helping to recommend interesting content. So in designing the Cognitive Cup, we wanted to reflect that broad set of applications in also as different tracks within the Cognitive Cup. And so we've designed 3 tracks. One is what we call ArtNet, and that explores the use of deep learning, of cognitive technologies for media, and in particular we were thinking about how to recognize paintings, how to recognize artists. So that cup track, we call that ArtNet, is invites you to build a database, maybe built on WikiArt, that consists of paintings, of artworks, and to use deep learning technologies to recognize styles of artworks, what painting style, what painter for example, might have painted a particular piece. We think that's a very interesting, a very insightful technology. It builds on image recognition technologies that have been benefiting tremendously over the past few years from innovations in deep learning. And so it's a interesting on-ramp to explore the capabilities of deep learning. The next track, we call that TuneNet, and that explores engineering applications of deep learning. And we invite you to in that track, to design technologies that help programmers write better programs. There have been several works recently that discuss how deep learning might be used to recognize bugs. And so a related area here that we might explore, that you might explore in this track, is how to use deep learning technologies to guide the programmers to write better, faster, more efficient programs by building an application that trains on efficient coding techniques. And when the programmer runs a program through that deep learning stack, the program, your application, might recommend ways to improve the code. And the third one, we call that URNet, and that's really opening up the application area to anything that you might come up with that might interest you, and how deep learning might be applied to those applications. Think about, for example, using deep learning to recognize different birds or to recognize specific whales. Recognizing whale migrations is a important topic for many scientists, marine biologists, and so recognizing particular whales is an important application for them. So with that, let me talk about the judging criteria. So URNet is really open to a broad set of applications, whatever you think might benefit from using deep learning technologies. Looking at judging criteria, looking at difficulty, we think ArtNet is a very accessible, interesting new technology application to image recognition, image analysis technologies that have been widely published, discussed, and there are many examples out there. TuneNet is probably a more advanced type of application because it requires you to create the corpus, to create a body of recommendations based on analysis of code patterns that you might automate with in the deep learning preparation phase. And URNet really allows you to really select your own level of difficulty. To assist you in developing these deep learning applications, we have pre-deployed deep learning frameworks that are applications that automate the training of neural networks, and graphical user interfaces to access that technology. And you also have the ability to use Spark to run many instances of these learners in parallel to accelerate the application, to accelerate the learning and get faster results. And as Randy mentioned, that is probably the ultimate application in this cup, where you combine both the parallelism that Spark gives you with the new technologies, the new ability to get insights with deep learning technologies. So with that, I want to give it back to Beth Ann, and we're looking forward to your submissions and your ideas here.
Thanks, Mike. Yeah, and I believe that we have questions open, so if you want to ask a question, please submit it through the Hangout, and we'll have time to answer your questions at the end. So now we wanted to take you through some site touring and demos, so I want to hand it over to Mike Hollinger to take us through the Getting Started resources.
Great, thanks, Beth Ann. So What we'll do is I'll take over the screen here, and I will start sharing my screen for a few moments, and you guys should be able to see the DevPost website. So what I want to do is show everyone really briefly the content we have available, show where you can go to get more information, and then actually show how to log in and get access to the instances and hardware that we have set up for challenge participants. So first and foremost, we've put a lot of content out under the DevPost website. You can very quickly look across the top of the set here and see that we have information for each of the 3 tracks within the challenge, between the Open Road Test, the Spark Rally, and the Cognitive Cup. We also have discussion boards that have questions that we can ask and actively discuss, and we have updates and information that we're pushing out to you. To get started and to really get in and start using the hardware that we've made available from Xilinx, NVIDIA, and IBM, check out the resources that are available here. The resources show you a straight line path to go from challenge registration, which I think everyone here is already registered within DevPost, to registering for access to the SuperVessel cloud where all this hardware is actually being stored. You can register on the SuperVessel website. We have screenshots showing the process on the website here. I won't go through that just to save time, but activation is as simple as supplying your email address, looking for an activation email, clicking on the link, and getting associated and activated. If you've already activated an account and you didn't go through the challenge participant activation link, then reach out to one of us on either Slack or the forums here. We'll need to give you some extra access and extra quota credentials so that you can spin up the multi-node clusters that Randy mentioned and really get access to the larger instances and the larger resources that we're making available. So with that said, there's really a couple of jumping off points. In the first case, we have a pretty extensive guide published up in Box that shows exactly how to get through creating accounts again, logging into the system, and accessing different parts of the resources that you need in order to access the Open Road enabled image. We've created a quick start for that purpose, so what I'll do is I'll show you guys how to go through that process. So what I'll do is I'll go back up and go out to the SuperVessel website. I've actually got the login already available here on my screen. So
Mike, I'm sorry to interrupt, but we lost your screen share.
Oh, okay. No worries. Thank you, Serena, for that. So what we'll do is we'll go back and I'll log in to SuperVessel with an ID that I created earlier. And what you'll see once we log in here is that really we'll be following along the same steps that are available in the Quick Start guides that are linked from the DevPost website. So what I'll do is I'll go through, find the Open Road Quick Start image, I'll launch it, log into it, and show you guys really briefly how to access it from within the web browser. So this is the main dashboard for the SuperVessel front end. If you're familiar with OpenStack, this is basically OpenStack. So our colleagues from Canonical have done a great job of integrating their software with the OpenStack suite. So what we'll do is we'll go to the image market and take a look at the available images. Each of these is built for different purposes. For developer challenge participants, we've created quick start images for you. In my case, I want to take a look at the Open Road Quick Start because this includes all of the software necessary to get started with C and C++ development, NVIDIA CUDA support, the IBM Software Developer Kit, which we'll talk about in a little more detail, and the Advanced Toolchain, which has some tuning software. Note that we have a separate image right now for IBM's XLC compiler, but we will integrate that into this image once we have XLC Community Edition available in the middle part of June. So look for that update. So I'll go ahead and click Launch, and when I launch, I have a couple of choices. If you signed up as a challenge participant, you'll be able to create an image that is actually quite a bit larger than our default small Docker container. The default small container, I think, will create a couple of threads with about 2 gigabytes of RAM and 20 gigs of storage. The challenge participants are able to create a 32-thread instance with 32 gigs of RAM and 40 gigs of storage. So it's quite a bit beefier, and also 1 GPU. So these are quite more substantial images, and they offer you the ability to do quite a bit more in terms of development and test. While this is launching, I should also point out that we have the ability to launch multiple nodes in a cluster. I think we'll talk a little more about that later, but there's a separate quick start guide for how that works. So I'll kind of go to the final part of my demo here, and within the web browser, show how to do an initial login for the system. If you click into the extra actions and choose console, this will bring up a in-browser console for the new instance that I just launched a few moments ago. You'll see that on the screen I can choose to log in with the default login. So I'll log in as OP user, and my default password of power user. Type that correctly. And since it is my first login, I'm required to change that password. So I'll log in again, and then change that to something else. So from this point, I'm actually logged into a Docker container. So if I take a look, I'm running inside of an Ubuntu LTS instance, and this is a Power 8 system. What's interesting about this is that, like we said, this is a 32-thread system, so you have quite a bit of resource available. We have 32 gigs of RAM that's enforced via Docker limitations, but we also have, for example, one NVIDIA GPU core that's a Tesla K80 available to me. And I can do quite a bit within the instance. This is, by the way, protected by a one-way VPN. So in order to access this machine over the network, which I can do, I have to launch a VPN client. There's a separate quick start guide for that. Once you are connected either via the web browser or via the VPN, you can, from this, reach out to the internet, but getting to this console again requires you to go through the web browser or through the VPN client. So to kind of prove that point, I can just go out to Canonical's web resources and do an apt-get update, and you'll see that the apt-get update just does what you'd expect it to do. So if I wanted to install something extra, for example, if I wanted to go get to apt-get, I don't know, elinks, so get an extra little browser for console stuff, I can go out and grab that package, and everything will just kind of come down. The key point is that because of how Ubuntu builds the images and builds up their resources and their repositories, everything that you'd kind of expect to work from an Ubuntu trusty LTS image will just kind of work here. So I think we've walked through the key things for how to get from the SuperVessel login to logging into an instance and kind of seeing what's there. Again, the key points are that we do have lots of resources available on the DevPost site, so please go check out those resources and take a look at the guides that are available both for getting started with the VPN, getting started with the different types of instances, and also getting started with the additional extra resource that's out there. IBM's put together with our partners quite a bit of documentation that will continue to grow over the course of the summer. So check back with us if you have questions, if there are common questions we will do our best to answer those things. So I think, Beth Ann, I'll hand things back to you, and we'll go to the next section of the presentation.
Great, thanks, Mike. And if anyone has questions for Mike, just please submit them through the Hangout, and we'll answer those in a bit. So I'm going to hand it over to IP now, who's going to show us how to use the Spark and Deep Learning notebooks.
Okay, hi, Bethan, can you hear me? Okay, good.
Yes, we can.
So, all right, thank you. So for this next section, what I have for you is how to access the Spark cluster and how to launch a Spark job with using an IPython notebook. And the key point I want to emphasize is that although it's a different platform architecture, you can more or less expect to, if you have Python skills, if you're used to running deep learning or analytic workloads using IPython notebooks, then you can continue to expect to use the same sort of skills in this platform. The platform should not come in the way. I have some examples to show you how to get started, and it's basically all documented, so I'm going to walk you through some of the things on the website, on the DevPost website. So I'm going to share my screen first. All right. So this is the main page for the OpenPOWER Dev Challenge, and at the bottom of the page, as Mike was pointing out to you, is a bunch of resources, documentation, and so if you click on this link here, that'll take you to the resources web page, and over there it'll show you how to. This has links to our forum and our Slack channel. If you have any issues, please feel free to drop us a note on the Slack channel, and we'll be able to respond and walk you through any issues. There are some instructions on how to configure a VPN client so that you can connect from your laptop to the machines that are part of this cluster. And I think we'll need to do that for Spark. Mike was able to show you how to access the console via SSH through the browser. While that might work for most cases, but if you want to access the notebook, you will have to set up your VPN connection. And then to launch your cluster, there are some documentations here which will show you how to launch, create a cluster for both the Open Road Test and for Spark Rally. For the Spark Rally and the Cognitive Cup, the second link is the one to use. And so I'm going to go to that documentation here in Box, and this is the documentation for creating the cluster for the Spark Rally and the Cognitive Cup. And as before, as Mike showed you, you walk through the process to create yourself a SuperVessel account, and then when you've done that, you can basically log into the SuperVessel console, which is an OpenStack Horizon console, and launch yourself a cluster for the Spark Rally. And the actual launch of the cluster takes, this is the link to the big data cluster. The launching process of the cluster takes roughly about 10 minutes or so. And I'm not going to actually launch a cluster. I'll use a cluster which I've already launched. And so I'm going to take you to that cluster next. So this is the SuperVessel Cloud, the OpenStack console, and I'll sign in. Okay, and so this is the link which shows the cluster which has been launched already. And so I'll click on the console, and that will show you how to access the master node of the cluster. I have created a cluster with, I think, 2 nodes. If you need more, I think if you reach out to us through Slack, we can perhaps get you some more nodes. And so what I'm going to do is, so I'm going to just take the IP address of the master node, because I'm going to need that to access the IPython notebook servers, which are already part of the containers which support this cluster. These containers have pre-baked installations for IPython and Spark, and a bunch of deep learning libraries such as Caffe, Theano, Torch, and TensorFlow. And so I will first walk you through, and for each of these deep learning notebooks, and for Spark, we have created a different notebook server. And there is a documentation here in Box which shows how to access the different notebook servers for each of these deep learning libraries. And here are some instructions to access those IPython notebooks. So I'm going to take the Caffe notebook URL here, and I'm going to paste it here, and I'm going to replace the IP address here to point it to my specific cluster's master node, which is something I'll get from here from the console in Horizon. And I'm going to paste it here. Okay, and so this is basically a Jupyter notebook. I'm just coming back from the Spark Summit, and I saw a bunch of presentations there and some demos which were all using Jupyter, and I also walked through some of the training classes that Databricks was conducting using IPython. So you should, if you are familiar with those notebooks, you should be able to get them running also here in this cluster. So I'm going to walk you through an example notebook which comes with Caffe, and this is the first example. And so what we do here is to simply get started. You click on each of the sections, the code sections in Python, and you either hit Shift Enter or you hit the play button here, and that runs it. And it's pretty quick. So so what this example is doing basically is taking a pre-trained model using the deep learning library Caffe, and it's taking a bunch of sample data, downloading it from the internet, and which is also coming from a well-known dataset repository, and it's basically classifying those images for that dataset using that model, the pre-trained model that's also coming from a well-known example repository for Caffe. So I just ran 2 of the notebook steps. In the third step, and this is the actual prediction step, and takes a couple of minutes here. So this is the predicted class, and the notebook, the example notebook, has enough documentation which can guide you through understanding what Caffe is doing, and you should be able to walk through all of those steps. And so this is the input image, and this is the next step. Will tell you what it was classified as. It's a tabby cat. And you can also see the difference that this classification, actually the training for this classification will take when you're using a CPU versus when you're using a GPU. And this next step here shows you that this is one of the training steps when it's using only CPUs, and it takes about, I think, 2 minutes, about 7 seconds per iteration. So we'll have to wait just a little bit to let this training finish. And the next step, okay, so just finished. So it took about 7 seconds per loop. And the next step, it is going to use GPUs for doing that, the neural network forward step. And in this case, it's very simple. Caffe does a very good job of, abstracting out the GPU exploitation code. And there's a configuration step which sets the usage to GPU. And then if you use GPUs, it's going to be much faster. As you can see, it's about 54 milliseconds compared to 7 seconds. So we got quite a bit of speed up here by using a GPU for one of these neural network steps. So I'm gonna, back to that documentation. Just want to show you that there are different URLs for the IPython notebook servers for each of these libraries, You're welcome to combine the usage of these libraries or use each of them separately. There's also digits installed and running on these notebook servers, and there's a separate notebook just for Spark. But also, as I was hearing in the Spark Summit, there are many teams who are now trying to combine some of these deep learning libraries together with Spark. And as both Michael Schrein and Randy Swanberg were pointing out, the ultimate challenge here is how you can combine and distribute the deep learning steps with a framework like Spark. I've seen some examples, Caffe on Spark, and TensorFlow on Spark, which have sort of initiated some steps in those directions. I think we are looking for some examples which go further along that route and show how many of these libraries can be distributed. Just one more thing that I'd like to show you here is about Spark itself. This is the notebook for Spark, and here we have some examples which just basically show how to get started with Apache Spark. If you're not familiar with that itself, then you might be able to just take one of these notebooks which show you how to create a RDD, which is that in-memory data representation, which helps to speed up all these distributed analytic jobs so that they become more like real-time analytics. And I'm not going to walk you through this example, but it's pretty fast. I think it's very easy to get started. But if you have any questions, we'll be on Slack, and please feel free to reach out. So with that, I'd like to turn it back to you, Bethan.
Great, thanks IP. So if you have questions for IP, please submit them in the Hangout. We're going to pass it over to Rafael now to talk about the Linux SDK.
Sure, thank you. So I will go through the SDK, which is a Eclipse-based IDE that allows you develop and optimize your C, C++ application for Power. So we have a set of tools that are developed internally by IBM and by IBM Research, and also community tools that we put together in order to make your code even better. So I created an account on SuperVessel, so I go to show you the easiest and the fastest way to get your application running with the SDK. So the first step is to install the SDK. I hope the image you are going to use already have the SDK installed, but I'm going to ensure that you can verify that. So let me share the basic my screen in order to show that. So in order so the basic and the easiest scenario to develop using the SDK is the synchronized one, where you get your application locally on your x86 laptop or desktop, whatever, and you connect to the remote roles. Then you synchronize the source code between those computers. Then every time you modify anything using your laptop, this change reflects in the server, in the remote server. This is the easiest and the fastest way to get the SDK running. So to do that, you need to go to the SDK landing page. And so we have a set of tools that help you install the SDK, but you can download the packages manually. So the first package you need to install to get started is the x86 version to install in your laptop. So you can go in your landing page over here and get the version according to your operating system. Then on the remote machine, you need to install a package called remote dependencies. We install everything we need to get the SDK running in the remote host. All the dependencies and packages necessary will be installed with this package. So the next step is, once you configure your environment and you have configured your access to the SuperVessel, you can start creating project. So the first step is to create a connection. So you can go to help, create my remote connections. Then here we are going to add the credentials to access your remote host. So let's do that for the super vessel. Create an account, connection name. Hope I spelled it right. My host IP, which I can't recall right now. What is that? Okay. Oops. And my user OP user. So I'm using public SSH key, so I do not have to type my password every time I need to connect. So okay, once I have created my connection, I just need to open it. And okay, I'm able to connect to the remote host and start developing. So okay, I'll create a simple project to show you how to do this. Within the SDK, you can select, we provide you a set of mechanisms to create projects. You can create a new project from scratch using the Eclipse infrastructure, or you can import your existing Makefile project or AutoTools project and work with those kind of projects accordingly. So here I'm going to create a simple synchronized project to show you how to do this. We have some kind of shortcuts in your left panel, so it will help you to save some time. So give your project a name. Select the connection, like we created just right now, superficial connection. Then select the kind of project you'd like to use. Here I'm going to create a Hello World AutoTools project, just to ensure you can save some time. Okay, so GNU AutoTools to change, things like that. You can go through all the users, set all their preference, things like that. And okay, done. Here I'm asked to activate the Build Advisor, which is a tool that we provided within the SDK that points problems related to the usage of compiler flags that can optimize your application to power. So if you are not using an optimized compiler like Advanced Toolchain, or flag switchers that can optimize your application like mTune and mCPU like Power 8 equals Power 8, sorry, it will allow it to show warnings asking you to set those flags. So let's activate this. Then if you look here, my source code is being synchronized with the remote host. So I created the project locally on my notebook, and now it's available in the remote host as well. So let me just go through. Let me show the console so you can follow what's going on there. So I'm going to reconfigure my project. Let me show that now. So what you saw here is that this project is running remotely in the SuperVertual in my SuperVertual account. So I compiled my application using the SuperVertual. Then I can build my application once it's configured. And okay, my application is built on Power. As you can see, PPC64LE. Also, you can have the output of the Build Advisor, which shows that I should set some other options, like use the Advanced Toolchain, which I didn't, setting M2 and mCPU, and other options that I could set here. So I think this is the basic step to get the application running. Then you can start to use any of the tools we have within the SDK. So I'm going to move to the chart where I can some example of that tool. One of the greatest tools we have there is called Migration Advisor. This is the tool that helps you exporting or moving your application from x86 to Power. So if you want to move your application, and optimize the source code. I mean, replacing code that are that should not work on Power. For the optimizer source code, you can use the migration advisor. We have a set of checkers that will make a static analysis of your source code and then point possible problems. And also for those also we have some kind of quick fixes that allows you setting and changing the source code automatically. So, but pay attention that these do not do all the job yet. We still depend on the developer evaluation about what we are proposing, because we do not want to break your application. We could provide a quick fix or a suggestion, but it is up to the developer accept it or not. Another tool that we provided and is integrated within the SDK is the FDPR, the Feedback Directed Program Restructuring, which allows you to optimize your application even more. So once you have compiled and optimized your application using O3, for example, you can run FDPR on your application, and it will provide optimize your application even more. So FDPR provides a set of switchers. You can select what you want to do, and at the end of the running with migration device, with the FDPR, it will provide a new binary, which is the suffix .fdpr, which allows you to. So this is a binary. You can run up your application, but it is optimized. So another interesting tool we have is the source code advisor. The source code advisor points problem in your source code. It is acting integrated with the FDPR, and it points problem in your source code and also suggests some solutions. In the latest available version of the SDK, the version 1.9, the source code advisor also provides quick fix for some problems. So it will analyze our source code and show what's going on wrong. So another application is targeted for looking inside your application. This is the CPI breakdown. Once you use the CPI breakdown, you can go and you can find the hotspots in your application, and also drill down to the source code, to the line of the source code which is causing that problem, and try to fix that. That is a tool that provides an overview of the behavior of your application. And also we have more tools. So we have a bunch of tools. I can't go through all the tools here right now because we don't have too much time for that. But within the SDK user's guide, you can find all the necessary information to use the tools we have. So here we have the last tool. So I would like to highlight is the Performance Advisor, which allows you to run your application, select a set of metrics, and will provide you the output, which allows you to analyze the metrics of your application. I actually use the PMU hardware events in order to get those metrics. So the SDK is a tool. In order to get the benefit of the SDK, you should use it. So we have a lot of tools that allow you to migrate, optimize, and optimize your application easily. So my name is Rafael. I'm on Slack as well. So if you need anything else from me, just tell me. I will try to help you as much as I can. So I think that's all for the SDK right now. Thank you.
Thank you, Rafael. And if anyone had any questions for Rafael, please submit them in the Hangout. And we're really short on time, want to have a few minutes for questions, but Yao-Ching, if you want to just introduce yourself and the XL compilers at a high level, and knowing that we can dive deeper into a special session for the compilers at a later. Thanks.
Sure. I'm Yao-Ching. I'm a technical leader from XL compiler, and I just give a very brief introduction how to use the XL compiler. And can you see my screen?
Yep.
Okay. Yeah, XR compiler supports C, C++, and Fortran, and at the binary level, fully compatible with GCC, and deliver the better performance. I think Mike already mentioned that this few steps, to get the XR compiler. Currently, XR compiler is not in the default image, and you need to follow the step 2 to click image market to select the XR compiler and to launch the XR compiler. So once you get there, and using XR compiler is pretty straightforward, especially if you have experience using the GCC or plain IBM, and it'll be very, very easy. And once you log on that, you can check which version. And we're using the lowercase c, XLC for C application, and the capital C for C++ application, and F for Fortran. You typically using the O3 or O3 hard for floating point competition intensive code, and O3 QIPA for integer applications. We also support the CUDA Fortran, and for C++, and we are integrated the CUDA as a host compiler. We also support the Fortran compiler. So we will have a separate the handout to focus on the detail to do the performance tuning with XR compiler. Today, that's all for today.
Great, thanks, Yao-Ching. So that concludes what we wanted to take you through on our kickoff and orientation hangout. I think we have a few minutes if there were any questions that came in. And for those of you that might view this when it's not live, please reach out in Slack or in the DevPost forum and let us know what specific topics you'd like more information on. And stay tuned because we'll be doing some more focused instructional sessions a little bit down the road. I don't know, Serena, did we happen to get any questions?
Yeah, we don't have any questions up right now, so I think that we're all set for the moment. But just like Beth Ann said, please feel free, everybody, to post questions to the discussion forum, post questions in the Slack channel. All of these folks are really willing and able to help you along the way, and we want to help you make the best applications that you possibly can. So we're really excited.
Indeed. All right. Well, thanks to our experts and thanks for everyone who tuned in. I really hope that everyone gets started and gets going in the Developer Challenge because I want to see you out at Supercomputing 2016 with your winning work. So thanks so much. See you guys soon. Thank you.
See you. Bye.
See you. Bye.
Thank you. Bye.
Thank you. Bye.